So, so we're discussing the cartel monopoly problem, and really the focus of your question is, well, like, how do I know how much output in general that the members of the cartel produce? And so in this equilibrium, the thing I think that was the missing condition is this last part, that it's true both that marginal revenue is equal to joint marginal cost, and that the joint marginal cost is equal to the marginal cost for each of the firms. So now if we go back to this diagram, I think maybe it should make more sense. And I'm going to go ahead and just to make this a little bit cleaner down here. So we'll lower the marginal revenue so it looks like the other diagram. And then, so based on this, right, I'm going to have a joint level of cartel output. And then for each of the firms, once I know what that, and you probably are maybe struggling for a bit of language to describe this, because obviously, see the green line that I've drawn, Michael? Mm-hmm. That is not, right, the marginal revenue function, right, which is this purple line. Rather, it's what marginal revenue is at a particular point on that function, the point where marginal cost crosses marginal revenue. So you might want to call this the equilibrium level, I put a little star on it, of marginal revenue that the cartel is earning. Does that make sense, Michael?
Yeah.
And then each one of the members of the cartel is going to earn the same amount of marginal revenue. And that's part of being in the cartel. You're going to get the same price. You're going to get that cartel price. So then for firm 1 and for firm 2, respectively, we can identify their contribution to output for the cartel as a whole, right? So I didn't label, Q1 and Q2, but hopefully that's clear enough, and you can see that this total monopoly quantity, right, is going to be Q1 plus Q2. So is that enough information for you? Are you?
Yeah, I think I could use like a more concrete example though. Like, how would you apply this to like an actual problem?
Well, I think hopefully it should be clear, but I will take a look really quickly. So here's the example of the problems that you were talking about, right?
Mm-hmm.
And it says, how much output will firm 1 produce as part of the cartel? Well, look at these other problems, right? So you have the joint marginal cost function. So you can begin labeling everything in that one diagram, right? And then you have how much output will the cartel produce? Well, from this question, because you said you're okay to question 3, right? Mm-hmm. To this question, you'll know what that equilibrium level of marginal revenue is that we referenced in the diagram, right?
Yeah.
And then for firm 1, you've got the marginal cost function here. You just set that equal to the MR star, and it's going to be a number like, 100 or whatever. And then you just have the Q here, right, for in the marginal cost equation. You just have one Q, and you can solve for it.
Okay, great, thank you.
You're welcome. And we'll do like a more concrete example of this kind of in passing in the stuff that we're gonna do today, because as we move on, this is our last major assignment, is this cartel assignment, and it's too bad because I don't think that it's gonna let me go back to the problems that I had before. Yeah, I don't think so. Oh well. Oh, maybe. No. Okay, that's fine. Okay. So what I wanted to start off with, and this is, because of where we're headed and what we're doing right now. So I want to talk about how to solve the Cournot problems, but remember, ultimately, and this was going to show up in the cartel problems a little bit later, implicitly, we're going to be comparing the four market structures that we've talked about, right? So you're going to, in the course of one problem on the final, you're going to talk about a competitive equilibrium and a monopoly equilibrium and a Cournot equilibrium and a Stackelberg equilibrium, and they're all going to be based on one problem, and you're going to be comparing them. Okay. And if you're wondering why, well, again, the big picture is this is all tied to the first fundamental welfare theorem that tells us that a competitive market is efficient. And so we want to see how big are efficiency losses in different circumstances that we might see in an industry. And the first one obviously is monopoly, but there are other industry structures like the Cournot oligopoly, but we're just going to do two firms, not 3 or 4. And because if you're going to take a class, which I recommend, industrial organization taught by Dr. Kerr, then he would extend on this and talk about other sorts of industry structures. But this is where we do our introduction to that material. Anyway, so what we're going to see if we look carefully and we compare apples to apples, right, using the same numbers, we'll be able to see what kind of loss in efficiency, right? And again, if you're thinking loss of inefficiency, at this point in time, you should know that our measure of efficiency is total surplus, or we've called it net social benefit, same thing, right? So we'll be able to see how much net social benefit is lost, or how much total surplus is lost. And also remember, we can call the loss of total surplus deadweight loss. So we could phrase the observation also by saying, seeing how much deadweight loss grows as we move to these different industry structures. And that has some obvious, hopefully to you as econ majors, and important ideas behind it, which basically is, when do economists, when does society need to worry, right? When you see not a monopoly, but you see an industry that's dominated by a couple of big firms, is that something we should be concerned about because of the efficiency loss? So anyway, in order to really carry that out, we have to be able to compare these things. So let's start with competition again, and everybody should be able to see this. And so what we want to do in this type of question is, let's start first with just basically the competitive equilibrium. And so this is a little bit of review, and I will ask Devara, you're at the top of my list. You there? Devara?
Yeah.
Yeah, okay. So I want you and Jeff Soria, you here? Jeff? And Michael Barbie, you here? Barbie.
I'm here, Professor.
Okay. So and I didn't hear you, Jeff, or you just okay. So let's choose. How about you, Miles? Are you here?
Yes, Professor.
Okay. So we will have Miles, Michael, Barbie, and Devara. Go ahead and work on this, find the competitive equilibrium, and then we'll come back in about 5 minutes and discuss it. And by the way, you all can ask really quickly if you need to, how to get started. Is there anybody who's worried about, like, oh, how do I get started on this problem?
Yeah, can you help
Yeah,
me,
I am.
Professor?
Yeah. Well, remember, right, the competitive equilibrium, right? You have a couple of guideposts. One is, right, supply equals demand, right? So we have a demand curve. You just don't have the supply curve, right? Does that help enough, or do you need more?
How do we get the supply curve then?
Okay, well, that's a good question. Does anybody know the answer to that? Okay, well, what you should know is, right, supply is, I'll put double equal sign, right, is determined by marginal cost. Does that make sense? Michael Barbie, or Miles, or Devara?
Yeah, it makes sense.
Yeah, so remember, and this is why I say, what's the first thing you would do? Like, you're stuck on this problem. So what's the first thing that you should do? There's always one right answer to this. At least in this class.
I don't know. I don't know what to do right now.
Well, okay, this is what you always do if you're ever stuck on a problem in this class. Graph it. You get me? Does that make sense?
Yes, it does.
Yeah. So if you graph this, right? And I don't even have to, but if you just put it out on paper, what you have, it's like a puzzle, you know, Michael.
Yeah, I'm just wondering where I'm going to put the marginal cost. Is it going to be horizontal or vertical?
Well, I don't know. I mean, these are graphs, right? So you just graph them. So I just graph demand. Now, if I graph both of these marginal cost curves, right, they're just going to be, so this should sound familiar, rays out of the origin, right? And since this is an illustration, I'm not like drawing them to scale because I know it's going to look basically like this. It's just that the slopes are going to be different, right? Right. And see, now if you agree that supply is determined by marginal cost, right? Remember that the market level aggregate, if I have two firms in an industry or 10 firms in an industry, right? Remember the industry supply curve is the horizontal sum of the individual firm supply curves, right? So if I call this one, so MC1 is supply 1, right? And you know, I mean, I don't know. So Michael, where did you take principles? Did you take it here? Did you take it from me?
No, Fullerton College.
Oh yeah. So did you have Francis Mummery?
No,
You know,
I believe it was
okay,
a female.
that's okay.
Nicolette
That's fine.
Rotundo.
Yeah. Well. Francis Mummery, he's the department chair at Fullerton College, and he's actually a good buddy of mine. I've known him for like 25 years. But so if you'd taken Francis's class, I know he would have told you this, right? That so this industry supply curve, and I'll just, you know, the industry level, you guys can decide what labels you like, right? It's just the horizontal sum of, and that's why you have to be a little bit careful, right? Because I got to put like HZ for horizontal sum of S1 plus S2. But does that all, like, you're like, oh yeah, of course, or are you still confused? Because we have talked about this already in the context of the monopolist. By horizontal sum, I just mean at each price you add up the two quantities that the firms are going to supply independently, right?
So I would put for MC1, I would put 4Q equals the demand curve and get that price, and do that
Well,
with
no, not at
MC2 and add
all.
the two up.
No, not at all, right? Because they don't each charge their own price in the market, right? There's a market price, which is where market supply and market demand intersect. There's only going to be one equilibrium here, which is, let me put a, it's going to be this one. right? Can you see the pink dot there? Where the red and blue lines cross?
Yeah, I can see it. I just don't know how to add up S1 plus S2. Is it as simple as just adding 4Q plus 5Q?
Well, this is why I'm being coy. Remember, in order to do the horizontal sum, we have to do that process I talked about last time, where we constructed the joint marginal cost.
Oh, inverse, add inverse.
Yeah, exactly. So you see, I've not done anything like weird or different. It's just that you got to remember, I mean, this is just math, right? If I was going to construct this function, which is the sum of these other two functions, but horizontally, right? And you're going to do that over and over and over again in this section of the course. So, I mean, I know I'm reminding you, and we're not close to the final, so it's no big deal, but you do have time to practice. So it's important to, like kind of be on notice that, hey, I almost every problem I'm going to face in this part of the semester, I'm going to have these two functions that basically represent marginal cost functions of two different firms. And then I've got to construct this third one that's not given. And yeah, you're right. Exactly, Michael. This, I kept dancing around, hinting, but it's exactly the same thing. The industry supply curve is just the joint marginal cost curve. So yeah, invert, add, and invert again, and then you'll get a function, and you can go from there to find the equilibrium. Okay. So are you good?
Yeah, I'm good now. Thank you.
Okay. All right. So I will give you all about 5 minutes to work on that. Hey, Michael, do me one favor when we get back and remind me to restart the recording, please.
Okay.
Devara, how did you get the joint MC?
I just did what I did for the Monopoly homework on number 15.
Does that make sense, Miles? So you have to go through that technique where you invert and add the result and then invert again. Does that make sense, Miles? Okay, you're kind of.
Can you show me?
Well, yeah, of course. Yeah, we'll show you. So let me do this down here. Okay, so you have MC1, and if you can go back to the other video, because we did exactly this, so hopefully it looks familiar, Miles. So you have MC1, right, which is just, and I'm going to write it this way because it's just easier. Does that make sense? It's 4 times Q1, right? Are you there, Miles?
Yes.
Okay. Okay, your voice changed a little bit. So, and if I'm going to invert this, Miles, what should I do?
1/4.
Yeah. So Q1 is equal to 1/4, right, times MC. And I could put MC1, but this is where the distinction, because we're treating them as the same joint marginal cost function, we can be kind of, imprecise here. This is the applied math part where we're switching variable names to suit our purpose. Right. So, and then, so what should I write now, Miles?
1/5 MC.
Yeah. So that's the inversion part. And then the adding part is, remember, my total output is going to be equal to the sum of what each of these two firms produce individually, right? So now I can just add these, right? So, and do you want to add them for me? Or, I mean, obviously, there's a common denominator issue. Right, Miles?
So 9/.
Well, you broke up a little bit, but I think you have it. But I'll just wait for you to finish.
9/20. Sorry, I think someone else's like mic is playing in the back.
Oh, okay. I thought that was you. I can look at the participants and mute folks, but I think it went away. So now we have to do the inversion again, right? And this is what we would call the MC joint, or we could also call this the market supply. See, it's the same thing, right? But sticking, with our notation here, right? So now we do our final inversion, and what should we get?
9/20.
20/9.
Yeah, right. So 20/9 Q, right? So, and I can put a little star there to indicate that it's, and is that what you got, Devara and Michael?
Yes.
You agree, Michael?
Yeah, that's what I got.
Yeah. So now we have the supply curve, and it would be even okay if at this point in time you wanted to change the notation to this to be PV, because that's what we've been dealing with before. Remember, Miles, we have PV is equal to whatever, that's our supply curve, and PB is for demand. So let's see. Okay. So can you all finish it up from here?
Yep.
Okay. So do you all need a minute, or have you already gotten it? Because we're looking for.
I've already gotten it.
Okay, so why don't you tell us, Michael, Barbie, what did you get for the equilibrium price?
Oh, for the price? Hold on. Yeah, I'm gonna need a minute. I thought I was getting the quantity.
Yeah, well, we need both of them, right? I mean, we're going to. I mean,
Yeah. I got 62.67 for the price.
okay. And what did you get for the market quantity?
28.19.
28.19. So do you agree with that, Miles?
Yeah, I got the same answer. Thank you so much, Professor.
Sure. So and I don't know if there's anybody confused at this point, but we just have, right, we have constructed a supply curve down here, and we have the demand curve right there, and we're just finding the intersection between demand and supply, right? Now, here's kind of a next part, right? And that is how much of the total output is being produced by each of these firms individually, right? So what is Q1 star and Q2 star? What are their equilibrium levels of production? Because we know they should add up to 28.19, but yeah, I mean, how are we? I mean, our next step should be, right, for Q, well, I'll write it this way. Q star is going to be equal to Q1 star plus Q2 star. So Q1 star is equal to what? And Q2 star is equal to what? So Devara, can you answer the question now? Can you find Q1 star and Q2 star? Are you?
Do I just plug in the Q star into the MC1 and MC2?
Well, no. See, it's kind of a fine suggestion, but one of the other things you can remember is, okay, we know for the competitive equilibrium we have to have supply is equal to demand, right?
Mm.
Right. But remember what defines the competitive equilibrium at the firm level is price is equal to, do you remember? Marginal cost for each of the firms. So I don't know if you remember this. I mean, obviously I know that I've said it, it's, you know, in your book and it's in the lectures, but does this sound, you should remember, right? Price is equal to marginal cost.
Mm-hmm.
Does that make sense, or?
Mm.
You're
So
like,
I'll put the price. I'll replace the MC1 and MC2 with the price.
well, no, right? So look here, and maybe this should be clear, right? So I know there's the price, right? There's the equilibrium price. I could put P star on the diagram, right? And I mean, I don't know if this helps. I'm only putting as much as I can, or I think is right, because I don't want to slow your roll if you're figuring this out. But for each one of these firms, I mean, look, I don't know, does this make sense, Devara? So here's the price, right? Firm one is gonna look at their marginal cost, or this is firm two, the way we have it on our diagram, MC2, you see? And they're gonna say, oh, I see this price in the market. I look at my marginal cost function. I set price equal to marginal cost to maximize my profits. And I'm gonna produce that quantity. Does that make sense, Devara?
So I don't put the price in the MC1, MC2.
Well, you said before you just like, like replace marginal costless price, and I don't know what you meant by that. But if what you meant is that yeah, I have this equilibrium price of $62 and I use it for each one of these, right? I'm setting the marginal cost equal to the equilibrium price and then solving for Q, then yes.
Okay, yeah, that's what I meant.
Yeah. Okay, because that's not what you said. So I was unsure that was what you were suggesting. But yeah, because in fact, right, then and hopefully again, that's why I say, and obviously drawing out the problem is meant to kind of like jog your memory. But then I can find the quantity for firm 1, and I can find the quantity for firm 2, and we should be able to see that, yes, in fact, they add up to the total quantity for the industry. Does that make sense, Miles? Are you on board?
Yes, Professor.
Okay, and what about what about you, Michael Barbie?
Yeah, I got it up to this point.
Yeah. So Miles, you want to tell us what Q1 is?
Okay, I rounded my numbers like a tiny bit different. So I have like 62.6 and 28.2, but I got 15.65 for Q1.
Well, I want to correct you just because, we want to be dollars and cents. It would be as precise as possible. So use the 62.67. I mean, that should be our minimum level of accuracy is 2 decimal places, because otherwise we're going to get sloppy and it's not going to.
Yeah, no, I think it's because I solved for Q first and I got like 28.199, and then I like solved that first.
Oh, okay. Yeah, okay. So maybe yours is more accurate.
Yeah, but it should be pretty close though. But it's
okay.
15.65 for Q1 and 12.52 for Q.
Okay, so I'm going to put Q1 on our diagram and Q2, and just so we can see them, hopefully this is lining up so everything's looking good to you all. And so you want to give me Q1 again, Miles?
I got 15.6.
0.6. I didn't get a letter. 5. Okay. 5.
And 12.52.
12.52. And do you want to add those two together just so we can verify? It's 28.19.
Yeah, I got 28.17. So like 0.0.
Yeah, so that would be close enough we have a rounding error issue, but for Ignition purposes, the number is big enough that 28.17 and 28.19 are close enough. I mean, if we carried this out to like 4-digit precision, then we would be like right on. And if anybody's interested in doing that, they can. Yeah. So sure enough, we have verified that our industry quantity is the sum of the 2 individual firms' quantities. Okay, so now we've kind of done just about everything for the competitive market case, right? But obviously, what would be the next step if we were going to continue our analysis? What have we not done? Do you have an idea, Deborah?
No.
No. Well, what do we normally do? So these first set of numbers, you know what they are? This is a description of the outcome, right? This is just like what we predict based on our theory is going to happen, right? But we didn't say anything about efficiency, did we? Remember, there are always two parts to every economic analysis you're ever going to do. One part is the descriptive part, right? It's just making a prediction about what are prices and quantities going to be. But the other part is to analyze efficiency. Remember, the first fundamental welfare theorem tells us competitive markets are efficient, right? So the thing that we haven't done, right, is we haven't talked about what we would call, welfare issues. That must sound familiar, Deborah, right?
Yes.
Right. So we're interested in consumer surplus, and we're interested in producer surplus. We're interested in total surplus, which again goes by the name of net social benefit. We also haven't talked about the profits for firm 1 and firm 2, which are closely related to producer surplus, but they're not exactly the same thing, right? So we could go ahead and calculate with all of the information we have, the profits and the consumer surplus and the producer surplus, and then we would be in good shape to discuss efficiency issues. So is there anybody that has a question about how to do any of that before we move on? Because again, whether you're doing Cournot or you're doing monopoly cartels or anything else, Stackelberg later, you're always going to be interested in this question. This is, really our central issue beyond prediction, right? We want to know, is this good for society? Is it bad for society? And the way we answer that question in economics is it efficient or is it not, right? So anybody? Questions, comments? Okay. So but again, this should be all obvious if you've or almost all obvious if you've gotten this far. Then you can see the consumer surplus, you can see the producer surplus, and then you would use the profit formulas in order. And I will write down one of the profit formulas, the one that tends to be most useful for these types of problems, just in case you guys forget. And so remember that profit is going to be equal to total revenue, which you can calculate for each of the firms, right? Because it's just going to be the price times the quantity minus their total cost. But the way you want to write total cost is, remember, the total cost is variable cost plus fixed cost. And in all of these problems, if you have a fixed cost component, it's going to be given. Can you see that, Michael Barbie? Right up here.
Yeah, I can.
So you have the fixed cost, and then what's missing is the variable cost. But remember that variable cost is related to marginal cost for each of the firms. Remember that, Michael? And I'll put it here. So let's do it in a different color. So remember, VC is equal to the area under MC. Okay. Does that make sense, Michael? Barbie, you feel like you can solve everything now?
Yeah, I feel okay right now.
Okay, well that's good. So now let's do this exact same problem, and let me see. But we'll switch it up, and so let's see. Chinlin, are you here this morning? What about Ruben Huerta? You hear Ruben?
Yes, I'm here.
Okay. So, and I have also Russell Barrett. You here? Russell? Okay. What about Shelby? You hear Shelby? Okay. Okay. And what about Ben Garcia?
I'm here.
Okay. So Ben, we need one more. And how about you, Michael Left? You were chatting with us earlier.
Sorry?
Michael Left?
Yes.
Yeah. Okay. So I'm gonna put Michael, you, Michael Left, Ben Garcia, and Ruben in charge of the next set of problems. So let me just put that in the chat. So Ben, Michael L, and Ruben. Okay. So now I want to do the exact same problem. Okay. But now let's look at it from a monopoly cartel perspective. Okay. So let's go ahead and see if it's gonna let me grab this stuff. Okay, so here's our same question. Okay, so instead of saying consider the competitive market, I'm going to say consider the monopoly cartel. Okay. How much will the monopoly produce? Okay. So before I let you guys work on this by yourselves for a minute, do you have any questions again about how to get started?
So in this case, since MC1 and MC2 don't have like that constant, it would just still be the same kind of inverse add inverse, but just without that constant in front of it.
Yeah, exactly. And just remember, if you were to go through that formula and those constants were 0, the formula would still work. Now, I do have to say that you try to invert something if you're really insistent that it's 0, you might run into a problem where at some point you're like dividing by 0. But in this case, with the way that we're doing it, I don't think that's going to happen. So you should be okay. But all those formulas, if at the end, all you end up with when you invert a function that's arrayed through the origin that has no intercept, is you end up with another function that's arrayed through the origin that has no intercept. So the intercepts just disappear. Anyway, I hope that helps. But yeah, you don't have to worry about the intercept.
All right, thank you.
It's the same technique. Yeah. Okay. So, was that Ben who was chatting with me just a minute ago? Yeah, Ben, do me a favor. I'm gonna give you all about 5 minutes to work on this, and I'm gonna pause the recording. So remind me to turn it back on if you would, please.
Okay.
Thank you. Thanks again. Okay. So let's explain what was done. So you want to go ahead and go, Ben?
Yeah, so first thing I did was the marginal cost 1, I inverted that to turn that into 4Q1 equals MC1. And then
anyway, I'm listening.
And then I did the same thing for marginal cost of the second. So 5Q2 equals MC2. And then I added those together. So my joint marginal cost was MC equals 20 over 9 QB. And then I set that equal to
yeah, so you have exactly the same thing you had before. You have this MC joint, right? And this is exactly what we had before. The MC joint, we said, is the market or the joint supply curve in competition, right? It has a different interpretation here, but the equations are the same, right? So you're saying MCJ is equal to 20 over 9 Q, right? Yeah. And is that what you got, Michael left and Ruben? Is everybody okay?
Yep.
Okay. And then what was your next step, Ben?
And then I did MC joint equals MR, and then I solved for quantity, and I got. Do you want me to say the answer?
No, that's okay. I just want to make sure we're clear. So the monopoly equilibrium, right? Quantity is defined by MR is equal to MC, the marginal revenue, right? And we don't have an equation for the marginal revenue yet, but do you have one there?
I just take I use like the calculus way, and I just took the the antiderivative of the demand function, and I got 260 minus 14Q.
Yeah, so actually what you did do, and I'll just write it here, and you got the right answer, but you said the wrong the wrong method. And so what you're doing is, remember that the marginal revenue, by definition, it's the derivative of the total revenues function with respect to output, right? So total revenue is equal to, and this becomes important forward to like follow the techniques here, is P times Q, but we know that P here is PB, right? It's from the demand function. Those are all the possible prices that can be sustained in the market. So I would write it like this. You can put PB there if you want. It's fine. That's where you get the equation from. But so total revenue then is going to be equal to 260 minus Q, and I'm dropping the B, but you can see where I'm getting it from, right? And I can, and then we multiply that by Q, and then we would end up with a quadratic equation if we went ahead and expanded, right, distributed the Q over the terms in brackets there. And I can do that really quickly. It doesn't really matter for our purposes, but just so if anybody's watching, they can see what we're talking about. Q raised to the 2 power. And again, to be clear, all I've done is taken that equation, the demand equation, substituted in there, right? And then, yeah, sure enough, because this is a quadratic, if we go ahead and we take the derivative, then we'll get what you said was the result, which is marginal revenue is going to be equal to 260 minus 14 times Q. And that's what you got, right, Ben?
Yes.
Yeah, and I want to point out for anybody who's not comfortable with calculus, because it's not required, right? The relationship, and in this class, we'll always be dealing with these linear demand curves. So if you don't know calculus, what you have to remember or write down is the relationship between a linear demand curve and marginal revenue is that it's the same equation with double the slope. That's it, right? So you want to then go ahead and take us home. So we ended up with our QM, our monopoly equilibrium quantity. We call it QM star. Think of it a special designation. What did you get, Ben?
I got 16.02.
Okay, 16.02. And Michael F, do you agree?
Yep, same number I got.
Okay. And Ruben?
Yes, I agree.
Okay. So now to complete this, right, we also need our PM star. And did you compute that, Michael F?
Wait, I'm sorry.
The monopoly price. Did you get that?
Yeah, I can do that right now.
Okay.
That is, I believe it's 147.86.
And I could put a dollar sign there. 147.86. And to get that, you just put the monopoly quantity back into the demand curve, right? To see what price could be sustained and all units be sold, right? Now, there's one other thing for sake of completeness we would want to do here, and that is, and we could do it either way. So it would be fine, whichever way you want to do it, you should get the same number. Remember that the equilibrium quantity for the monopolist is where this marginal revenue and marginal cost curves intersect, right? So at that particular quantity, marginal revenue and marginal cost are equal to one another. So it's an equilibrium level of, I'll put MCJ star is equal to MR star. They have the same value based on the way that we constructed our solution. So, but what is that value? And we want to take note of it, because when we begin to ask questions like, well, how much does each of these, in this case, it's firms that are banding together, it's like individual factories being run by the same management, right? The collective management of the cartel, how much do they each contribute in terms of this total output? In the same way that we did for the competitive firm case. So this is what we were talking about at the very beginning. Remember, Michael left. So when you were asking, well, how do we, disaggregate the contributions of the individual members of the cartel? So we need this value, and so do you all want to tell me what it is? Do you see what I'm talking about, Ben?
I'm so sorry, Professor. Can you repeat that question one more time? I got a little lost.
Yeah, so my point is just that we have the monopoly quantity and we have the monopoly price, but since we're dealing with a cartel, we're anticipating, oh, we're going to need to know how much does factory 1 make of this total output? How much does factory 2 make of this total output? And in order to answer that question, we need to know what's not just, so I'll go back here. So this is a basic monopoly diagram, right, Ben?
Mhm.
We need to know this value, which is, so we found the quantity where marginal revenue crosses marginal cost, but we don't know the height of the functions at that value, right? Normally in competition, this would be like finding the price, right? But in monopoly, it's not the price where they cross, right? Instead, it's this equilibrium level of marginal revenue that each of the firms is earning, or what is their shared marginal cost value at that level of production. So we need to know that. We need to know that because otherwise we won't be able to disaggregate the output, right? See, QM is composed of Q1 plus Q2. I don't know Q1 and Q2 unless I know the monopoly equilibrium level of marginal cost. It's equal to marginal revenue. So that's what I'm saying is, in order for this to be complete, we have to compute that shared value where marginal revenue crosses marginal cost. So I'm asking so now what would you do to find that value?
Would you take the quantity output, so like the 16.02, and then plug that in to your joint marginal cost function? That
would be really easy. That's one way, and you could also plug it back into the marginal revenue, right? Because they're both going to have the same value at that point. So yeah, so the kind of the next step, and I'll just do it the way that you suggested, is to plug this in there, right? And then that's going to give me that value. So since this is kind of your question, Michael left, why don't you tell us, what did you get?
35.62.
Okay, so that's $35.62. Is that what you got, Ruben and Ben?
Yes.
Okay.
Yes.
Yeah, and it looks good to me, because 20 divided by 9 is almost 2, right? And 16 times 2 is 32. So it's close. It's a little bit more than 2 because the denominator is smaller. So yeah, that looks right to me. Okay. So then our our kind of like last step in characterizing equilibrium is we'd want to calculate the contributions of each of the firms to total cartel output. So does anybody have a question about how to do that, or can you do it?
I think I'm okay with that step.
Okay, and so you want to go ahead and compute it then?
Yeah,
Ben?
for Q1 I got 8.905 or 8.91.
Okay, so I'll put 8.91 units. And what about for 2?
7.12.
7.12. Okay, and what about you, Michael, left? Are you comfortable? And Ruben, are you comfortable?
Yeah, I got the same answer.
What about you, Ruben?
Same.
Okay. And so does anybody have a question about how we computed those numbers? I'll be, oops, I don't want to do that. I'll be explicit, what we do is we just take and plug these values in here and solve for Q. And so notice that the way that the firm is maximizing its profits and minimizing its cost is it's distributing output between its 2 factories that it manages, right? The cartel manages, such that the marginal cost of producing at each factory is the same, right? So they're both going to have this marginal cost of $35.62 per unit for the last units that they produce. And notice also, do you notice, Michael left, anything that you want to, maybe you can observe about, oh, well, because of this feature of factory 1, we're doing such and such with output, and with factory 2, we're doing such and such with output. Do you notice a pattern here?
Not really. I mean,
Well,
like Q1 plus Q2 equals the
16.
other Q. But
Yeah,
like,
so they add up together to this. But notice, right? So see factory 1, the coefficient that describes its marginal cost, right? It's less, right? So 4 is less than 5, which means that the marginal cost of producing in general at factory 1 is less than at factory 2, right? So you could call factory 1 the low cost factory and factory 2 the high cost factory, right? Does that make sense, Michael?
yeah.
And then notice you produce more intensively, right? 8.91 units in your low cost factory, and you don't produce as much output at your high cost factory. So the low cost factory gets utilized more intensively because the firm's trying to maximize profits. Do you see what I'm saying? Does that make sense, Michael?
Yeah.
Yeah. So, and we see it here in this diagram too. The orange line would be the low cost factory, the yellow line, the high cost factory. And sure enough, right, the low cost factory gets utilized more than the low cost factory. So that pattern shows up in the way that our output's distributed. It's not like, you know, an equal division, right? It's not like they're both producing exactly like 8.01 units. If it was the case that you know, the factories had the exact same cost structure, then they would be utilized equally. But to the extent that one of the factories is more efficient in the sense that it can produce at a lower cost, it'll be utilized more than the high cost factory. Anyway, that's just something that's implicit, that falls out of our, and it makes perfect sense, right? That if you're trying to maximize profits, you would utilize your low cost resource first. But yeah, that's comes out in our mathematical solution. So now, and I'll ask, so Ben, so now what's missing from our analysis? Because here it should be pretty clear, hopefully, that what we've done so far is we've just described the equilibrium, right? All this stuff down here tells us me a quantity and a price and a quantity for each of the firms. Those are just purely descriptive issues, right? So what will we do next then?
Find the profit for the cartel or the monopoly.
Yeah, right. It's the same thing as before, right? As we're interested in welfare issues, right? And what are all the welfare issues that we listed before, right? We want to know consumer surplus, producer surplus, right? Total surplus, and the profit for each of the firms, right?
Mhm.
And then notice in particular, and this is because of the first fundamental welfare theorem, in competition, there is no deadweight loss, right? But here, what we're going to notice is there is a deadweight loss, and the deadweight loss, you could try to compute it, you know, like using your graphs, and you would be okay at this point. But eventually, you're going to have to rely on this definition, which is the deadweight loss is the change in total surplus. So in this part of the class, we're going to, next we talk about Cournot, and then we talk about Stackelberg equilibria. And I'll tell you something kind of funny, and I'll just chat with you for a minute, Michael Left. How are you doing? This is to help you so you remember. Are you all good with everything so far?
Yes.
Well, when we talk about deadweight loss, right, you probably typically associate that with, and I'll just draw it on this diagram, and you tell me if this looks familiar. I'll put it in yellow here. Is this triangle over here, right? Does that look like deadweight loss to you?
Mm-hmm.
Right? But it turns out as we move on to talk about Cournot and Stackelberg, it's no longer possible. And I've had many students when we were, you know, on campus, come to me repeatedly and try to identify the deadweight loss associated with Cartel or Stackelberg on a diagram, and it never works out. So you, at this point, and just so you kind of like know, so the way that economics generally evolves is we get much more dependent on the equations and less dependent on graphical representations. The graphical representations become like how I'm using them, sort of, just mere illustrations of what's going on. And sometimes illustrations are useful and sometimes they aren't. But the underlying mathematics will never cause you trouble. So when we calculate deadweight loss, we're always going to use the total surplus in our particular situation. And in this case, it's monopoly. So I could call this total surplus, and maybe I should write it with different brackets just to make it look a little bit more clean, at QM, right? Minus the total surplus at QC for competition. And whether this is in fact monopoly or it's some other like Cournot or Stackelberg or whatever, I'm just going to replace that total surplus associated with the quantity of output under whatever it is, and it's always going to be benchmarked against the total surplus under competition. There's only one other thing that I should be careful about, and that is this calculates the change in total surplus for me, but technically speaking, if we're talking about deadweight loss, it's going to be the absolute value of that change. So if there's one thing, I mean, not that there's not a lot else to remember, because there is, right? But if there was something I was going to suggest that you tuck away someplace, if you have a list of formulas or whatever that you're going to be using, it's this one for deadweight loss. Because, and make sure you know that ABS stands for absolute value. I could, just put, pipes here instead. So if you all prefer this kind of notation for absolute value, that's fine too. But you're going to be calculating the change in total surplus relative to competition and showing that in all other cases except for competition, because obviously if this was QC, then that amount would be zero. And that's what the first fundamental welfare theorem tells us, is that there's no deadweight loss associated with competition, period. And then for all these others, we'll end up with a smaller total surplus and a decline in total surplus is a decline in efficiency. That's how we define it. So, okay. Any questions about that? No, I'm guessing. All right. So how do you feel, Michael? Are you pretty comfortable now?
So I guess the next thing to do would just be to figure out how to calculate total surplus.
Yeah, exactly. And in this case, because we're dealing with monopoly and there's no tax or anything, the calculation is pretty straightforward. It's just consumer surplus plus producer surplus, which you can identify pretty easily on the diagram. I mean, I don't know if you're having any doubts or struggle, but if you can ask if you want. This is hopefully a familiar diagram. The area up here, right below the demand curve and above the price charged by the monopoly, is going to be the consumer surplus, right? And the producer surplus is going to just be this area here, which is below the price and above the joint marginal cost, right? And if you go through the lectures carefully, then you'll also find that there's another formula that you can use, which is the total surplus for the monopoly ends up being, and I told you producer surplus and profit are very closely related, but you could write it as the producer surplus for firm 1 plus the producer surplus for firm 2. But it turns out that the producer surplus for any firm, but I'll just say for firm 1 here, is its profit plus the fixed cost for that firm. So producer surplus is higher than fixed costs. I mean, let me say this: producer surplus is higher than profit, and the difference between the two is the amount of the fixed cost. Now, I don't know if that makes sense to you. I say this in passing in the videos that are recorded on the topic, and I'll say it really quickly here. And if anybody wants to talk about it, we can talk about it really quickly. But the reason that producer surplus includes the fixed cost component is that fixed costs are assumed to be something that are unrecoverable to the firm, and you know, this is a little bit nuanced, so if it's not perfectly clear, it's okay. It's just something to think about. But I can tell you the logic of it or the reasoning behind it, and then you're kind of entitled to disagree if you want. But this is just what economists do. So total surplus and welfare are supposed to be forward-looking measures of how society is doing, right? So because they look forward, and fixed costs are something that are already incurred, any payments that go to recover fixed costs are benefits that wouldn't otherwise exist. And again, what I mean by that is, you know, assume you built a factory and you paid $1 million for that factory. That cost, being a fixed cost, is assumed sunk or unrecoverable. If your market goes away tomorrow, there's nothing you can do about your factory. I'm sure you could potentially sell it, and that's fine, but it depends on the way that you think about it. If you really think that your technology is tied to a product that is no longer valuable, then it doesn't make sense to sell your factory because nobody else will want it, right? If you know, and this is one of the things that I kind of think about, is you know, it happens with technology all the time, and maybe, you know, I've just seen it more than you guys have. But you know, I've been, when you think about you know, audio technology, right? When I was a kid, we had these bulky 8-track tapes, and we had vinyl records, and then we got the smaller cassette tapes, and then we got CD disc player Walkman, and then, you know, we got MP3, MP4 players, and now lots of people just use their phone, right? Well, if you have a factory for producing cassette tapes and that technology gets supplanted by something new like MP3, MP4 technology, right? You know, obviously that transition takes a while. So the factory doesn't instantly lose all of its value. But, you know, you know, if you think about really, you know, in a couple of years, that cassette tape factory is worth nothing, right? So to the extent that you incur fixed costs in production, those costs are, from a forward-looking perspective, they're unrecoverable. So anything that the factory owner gets that helps cover those fixed costs is a benefit that they're receiving above and beyond what they could otherwise expect. So anyway, that's why we add the fixed costs back. You don't have to remember all that, but remembering this formula can sometimes make it easier to so I'll put profit for firm 1, fixed costs for firm 1, profit for firm 2, fixed costs for firm 2. Sometimes it can make it a lot easier when you're working through the problems, because if you've already computed profit and you already have the fixed costs, instead of drawing out a diagram, you can just add the numbers and move on. It can be quicker. That's also, these formulas hold up outside of Monopoly too when we talk about Cournot. And again, when I said in Cournot, you won't be able to draw a diagram, you'll have to use these formulas. Okay. So now I think we're ready to talk about Cournot. Now that we've summarized monopoly and competition. And again, we're going to do exactly the same thing. So this, instead of being a monopoly cartel, is going to be a special form of oligopoly. I'll say a Cournot duopoly, right? And our first question would be, how much is going to be produced in the duopoly? Now, I don't know. I mean, I assigned you on Tuesday to watch those Cournot videos, and they're doing exactly what we're doing right now. So I'll ask, let's see, our participant list. So I got Joshua, you here?
Yeah, I'm here.
Okay, and what about Nardine? Are you here? I'm not getting Nardine. And what about Noah Mendoza? Okay. And how about Tommy Nguyen? You here?
Yes.
Okay, Tommy. And what about Michael Bruno? Oh, he's not showing up with a mic. So we go back to, how about Newtonicha? Okay. So we have Noah and Joshua. So I'll talk with Noah and Joshua. So if you were gonna try to solve the and I don't know how intensely, hopefully intensely, you watch the Cournot videos that I assigned, but what would you do here? You have any idea, Noah or Joshua?
I remember in the videos we talked about residual demand, but we're doing the output for both, so I'm a bit confused.
Yeah, right. And so that's exactly where we would start. So we kind of have this new concept, and for Cournot, so sort of like in the cartel monopoly problem, right? We had to construct a joint marginal cost curve. So there was like a missing step, right? There's a missing piece of information that you have to, bring to the table, like how to construct the joint marginal cost curve. Here under Cournot, there's another thing that you have to do, and that is you have to, so I'll say step one, construct the residual demand. And it really, you're going to need a residual demand curve for each duopolist, right? So you're going to need a residual demand, I'll just say, for firm one, and you're going to need a residual demand for firm two. Now, I'll just talk about residual demand in general. Okay, so you have your initial demand curve. In this case, we have PB is equal to 260 minus 7, and I'll put times cap Q. Okay, but you should remember that cap Q is equal to Q1 plus Q2, and then do that substitution immediately, right? And maybe I'll do that. It's a little bit cleaner, right? And then we'll write PB is equal to 260 minus 7 times Q1 plus Q2. Okay, so you see what I've done, Joshua?
Yeah, dude, that makes sense.
Yeah. So now the key is that if you're, for example, going to construct the residual demand for firm one, let's just call it P1, right? Then that means that you're treating Q2 like it's a constant. So I'll say for firm one, residual demand, treat Q2 as a constant. And we're kind of limited by what we can do in terms of notation. So I'll just write Q2 with a little hat. And that just means you're assuming it's some number. You don't know what the number is yet. But the idea is that the firm one is going to maximize their profits as if they were a monopolist on their own, but taking the output of firm two as given at some level, right? And the reason they're doing that is that the amount of output that firm two is producing, right, is going to help firm one identify what part of the market is available to them, right? So if you just think about, in terms of the equations, and so let's just say, suppose, for example, we don't know this, Q2 hat is equal to 20 units of output. So again, suppose you're thinking, you're from one and you're like, I want to maximize my profits. How much should I produce? And that's always your question in these, this is a Cournot, what they call a quantity setting game. So you're trying to pick your quantity to maximize your profits as firm one. So the logic is, well, if I know that firm two is already producing 20 units, let's just assume they're not going to react. And this actually gets into the Nash behavior assumption, right? And so in Nash, the way that the Nash equilibrium works is the Nash equilibrium is each player playing their best response, assuming that the other player isn't going to change their behavior. Okay. And so oftentimes the Nash strategy or the Nash action that's taken by a player when the Nash equilibrium is described is referred to as a best response strategy. So you're just going to do the best you can given what the other player is doing. But we don't know what the other player is doing yet. We'll find that out in equilibrium. But whatever they're going to do, we're going to play our best response. And best in business is always most profitable. So this is a particular application of Nash game theory to production decisions. So the best response strategy is to maximize your profits, whatever the other player is going to do. Okay. So if we thought that the other player was producing 20 units, then look at what happens to our demand curve, right? If I let Q2 be fixed, then I can, hopefully this makes sense with me, Joshua. If I write this, does it make sense to you? So this would be the residual demand. So I could put PRB, okay, for residual, right?
Okay.
Then I would have 7 times 20, which is 140. I'm looking at the terms in the brackets there, right? And I got minus 140 and plus 260. I would have 120 minus 7 times Q1. So I just reduced everything, but does that equation make sense to you based on what I did?
I'm sorry, where'd you get the 120 from again?
Well, okay. So I said that Q2, right, is equal to 20.
Yeah.
So if I put 20 in here, I get 20
Oh, so you just reduced it.
minus 7, right, which is 140. And then I'm just, I could write this up here and that would be okay. Let me just try to pick a different color because I don't want to really goof things up too much.
Yeah, I'm following what you did now. It just took me a second when you said you got the numbers from the bracket, but I see what you did now.
Yeah. So what I did, and let me see if I can again, is I just reduced everything from here to 60 minus 7 times, and Q1 is still what it is, but I have plus 20, right? And then obviously, if I go ahead and reduce this equation to, what's left over, right? Then I end up with an intercept. So notice it has the same slope as the original demand curve, but the intercept has been changed, right? Because of this assumption. So that just gives me, some insight. So I'll just say, so generally, right? So that was a specific example to kind of show you what the thinking was. But I'll say generally, we would get PRB is equal to 260 minus 7 times Q1 plus Q2, which is a fixed value. And you could rewrite this and it would be fine, but notice you're going to have this intercept term, and this is kind of the important part. 260 minus 7 times Q2 hat. That's going to be the new intercept term minus 7 times Q1. Okay. So maybe this would be a little bit clearer if I write PRB. So I just rearranged the terms. And I'm going to switch this now from PRB to residual demand for firm 1, right? And then our next step, right, is remember that profit max always implies that marginal revenue is equal to marginal cost at the profit max Q1 star. Okay, so the only thing that we're missing is we have residual demand, but now with residual demand, we have to construct a marginal revenue function. And technically speaking, you could call this the residual marginal revenue function because it's based on the residual demand, but that's, it's just language. So you could just say the marginal revenue firm 1 in this given their residual demand is, and I'll just write that again. This would be based on total revenue and total revenue with respect to output. But note that because everything again is linear, you're just going to have, let me see if I can copy this. Okay, you're just going to have 2 times the slope, right? Remember, this part is constant. So the part with Q2, because it's a constant, it's treated like a constant when you take the derivative, and you end up with this as being your marginal revenue. Does that make sense, Joshua?
Yeah, that makes sense.
And okay, and what about you, Noah? Did you have any questions about what we did? Noah? Noah, are you still here? Okay. So we can pick up here next time. Hopefully you can see, Joshua, that the next step would be to set marginal revenue, right, equal to marginal cost. And that's where we'll start off next time. Okay. Does anybody have any questions about this? Because we're out of time. I'm going to go ahead and